We will start nuclear physics with general properties of the nuclei. In general properties of nuclei, basically I will discuss what are the constituent particles of the nuclei, how can we express or how can we denote the general nuclei expression basically. After this we will discuss nuclear mass, nuclear radius, nuclear density, material density of the nuclei or mass density of the nuclei, particle density of the nuclei, and in the last we will discuss the binding energy of the nuclei. So I am going to start this general properties of the nuclei by introducing an atom. So in an atom we have a central part, and around this central part there are different orbits. There are different orbits in which electrons revolve. So the central part of the atom, is known as nuclei. So basically the atom is made up of the central part, which is carrying positive charge, and this part, central part, which is carrying the positive density as well as most of the mass of the nuclei, is concentrated here in this center. So this central part, which is positively charged as well as it carries all the mass of the atom, this is known as nuclei. This is known as nuclei. So nuclei is the central part of the atom which carries total positive charge as well as most of the mass. This positive nuclei is surrounded by the electron orbits. These electrons move in certain orbits like this. So electrons are here in different orbits. You are aware about these. These orbits are represented by K, L, M, N like this. So basically in nuclear physics we are interested in the central part of the nuclei. This central part of the nuclei is made up of two types of particles, or you can say that the constituent particles of the nuclei are two particles. One of the particle is known as protons, and other type of particles are neutrons. So there are two types of particles which exist inside a nuclei, protons and neutrons. These protons, as the name suggests, this carries positive charge. While this neutron is a neutral particle. So basically the central positive and the part which carries most of the mass, this is known as nuclei. This central part consists of, or its constituent particles are protons and neutrons. Protons are positively charged and these neutrons are neutral particles. One proton carries plus E charge. So one proton carries, if you consider one proton, this one proton will carry plus E charge. So basically there are two types of particles inside the nuclei, and combinedly these two particles, proton and neutron, together they are known as nucleons. So both these particles, protons plus neutrons, they are known as nucleons. Protons is known as nucleons as well as neutron is also known as nucleon. Nucleons because they are found out inside the nuclei, so they are represented combinedly as the name nucleons. So here the mass of the proton, if you consider the next thing is mass of this proton is nearly equal to 1.007 AMU. AMU is atomic mass unit. Later on we will define this AMU, but right now mass of the proton is 1.007 AMU and mass of the neutron is 1.008 AMU. So from here you can find out that mass of neutron is little bit higher mass of the proton. So mass of neutron is little bit higher as compared to the mass of the proton. If you consider the mass of these electrons, this is 1/1836 times mass of proton. So this mass of electron is equal to 1836 lesser 1/1836 times the mass of the proton. So this mass of proton is much lesser as compared to the mass of the proton. So we can say that mass of electron is less than the mass of the proton as well as mass of the neutron. So from here it can be confirmed that because mass of the electron is very less, this is 1/836 times lesser as compared to mass of the proton and neutron. So automatically most of the mass of the atom is carried by these two particles, protons as well as neutrons. So due to this reason, most of the mass of the atom, you can say that most of the mass of the atom is carried by nuclei. This is one of the important things of the nuclei. Another is the charge. Charge on this nuclei is positive. So total positive charge of the atom is capped by this nuclei. So total positive charge is here inside the nuclei, and negative charge is here in the form of electrons which are revolving in different orbits around the nuclei. But if you consider an atom, then an atom as a complete entity is neutral. So as atom as an entity is neutral. It means positive charge in an atom is equal to negative charge. So total positive charge in an atom is equal to the total negative charge. Here charge carried by a proton is equal to plus E, and charge carried by an electron is minus C. So both proton and electron, these protons and electrons, they carry equal charge, but their nature is opposite. This electron carries negative charge while this proton carries positive charge, but their charge is equal but opposite in nature. So they carry equal but opposite charge. So because total positive charge is equal to total negative charge in an atom, it means number of protons is equal to number of neutrons. Number of protons are equal to number of electrons here. This is negative charge, so this is number of electrons. So number of protons is equal to number of electrons. Why they are equal? Because this proton carries plus E charge. This proton carries plus E charge, this is carrying minus E charge, and because positive charge is equal to negative charge, so number of protons will be exactly equal to number of electrons in a neutral atom. So this is another important thing about the atom, that all these protons exist inside the nuclei and they are carrying the total positive charge of the atom, while all these electrons which are carrying negative charge, they are revolving in different orbits outside the nuclei. So basically, what are the constituent particles of the nuclei? Protons and neutrons and electrons electrons revolve outside the nuclei. Electrons doesn't exist. Electrons do not exist inside the nuclei. They revolve only outside the nuclei. One can easily prove that electrons cannot exist inside the nuclei. In exam or in an interview, they can always ask you that prove that electrons cannot exist inside the nuclei. So we will answer this question later on, but right now we can say that total positive charge is concentrated inside the nuclei while the total negative charge is carried by the electrons, and these electrons are revolving in different orbits in different orbits around the nuclei. Now how can we represent a nuclei? Now, next question arises, how can we represent a nuclei? So, general procedure to represent a nuclei is ZXA. This is the general notation of a nuclei. Here, this X is any particular nuclei. It can be hydrogen nuclei, it can be carbon nuclei, it can be nitrogen nuclei. So, this X is an arbitrary nuclei. Where this Z is known as atomic number. This Z is known as atomic number of the nuclei. And this A is known as mass number of the nuclei. Mass number of the nuclei. So basically, a nuclei is represented by ZXA. This is the way to write down a nuclei. ZXA, where Z is atomic number and A is the mass number. What is the meaning of atomic number? This Z number is always equal to number of protons. Always remember that this Z number is always equal to number of protons. It's not equal to number of electrons. In neutral atom, protons and electrons are equal. So Z will also be equal to the number of electrons also. But the atoms can convert into different ions. It can create positive ion, it can create negative ion. So number of electrons can differ. But number of protons inside the nuclei is fixed. Whenever you will change the number of protons inside the nuclei, then nuclei will change. It will change from one nuclei X to another nuclei Y. So for a particular nuclei, number of proton is fixed. So this Z number is always equal to number of protons. This is always equal to number of protons. And this A number, mass number, this is equal to number of nucleons. Number of nucleons inside the nuclei. Number of nucleons inside the nuclei. Inside the nuclei. So basically, this A is equal to N, number of proton, this NP, number of proton plus number of neutrons. So A is equal to NP plus N, where NP is the number of protons plus NN is number of neutrons. So number of protons plus number of neutrons, that is equal to the mass number. So a nuclei is represented by ZXA, where Z is the atomic number and A is the mass number. For a nuclei, this Z number is fixed, and this Z number is equal to number of protons, while this mass number A is equal to number of nucleons inside the nuclei. What is nucleon? Nucleons are protons as well as neutrons. So always remember this thing. First important property. Now come to the different general properties of the nuclei. First important property of the nuclei is nuclear mass. So first important property which we are going to discuss is nuclear mass. Nuclear mass. What is the meaning of nuclear mass? Mass of a nuclei is known as nuclear mass. Mass of a nuclei is known as nuclear mass. And how can we find out this nuclear mass? There is a simple formula for the nuclear mass, m nuclei. So this is the mass of the nuclei. This will be equal to, suppose the nuclei is ZXA. Here I am assuming that the nuclei is ZXA, and we have to write down the mass of this ZXA nuclei. So what will be m nuclei, mass of the nuclei? This will be equal to Z times mass of the proton. How many protons will be here in ZXA? In this nuclei, what will be the number of protons? Number of protons will be equal to this Z number. This will be equal to Z number. So Z times mass of the proton, because number of protons inside the nuclei is Z. So I have multiplied this Z number with MP, mass of one proton, plus how many neutrons are there inside the nuclei? What is the number of neutrons inside the nuclei? That will be Nn, and Nn will be equal to A minus Z. Why this is A minus Z? Why this is A minus Z? Because this Nn, this A number is equal to, kitna hota hai beta? This is Nn plus Np minus Np. So this will be equal to Nn. So from here we can write down that number of neutrons in a nuclei is equal to A minus Z. So here, what will be the mass of the nuclei? Z times mass of the proton. Similarly, number of proton will be equal to A minus Z into mass of the neutrons. So here, these two terms gives us the mass of the constituent particles. Nuclei is made up of two types of particles, protons as well as neutrons. So what is the mass of the constituent particle? This is the mass of the constituent particle. This should be equal to mass of the nuclei, but this is not the case. But experimentally this is not true. Mass of the nuclei is always less than. Mass of the nuclei is always less than. You will find out that mass of the nuclei is always less than mass of the constituent particles. Mass of the constituent particles. Constituent particles. So basically, when a nuclei is formed from the constituent particle, a small mass is lost, and that mass is known as mass defect. That lost mass is represented by delta M. So this will be this. So basically, mass of the nuclei is always less than the mass of the constituent particles, and a small mass will be lost. And this lost mass is known as mass defect. This is known as mass defect. This mass defect will convert into the energy. This mass defect will convert into the energy. And how much energy will be released when delta M mass will be lost? Then released energy will be equal to delta E. And delta E will be how much? It will be given. We can calculate this delta E corresponding to delta M by using Einstein mass energy relation. That is delta M C square. So this will be the energy released due to this mass defect. So what is happening here? A nuclei is formed from Z number of protons and A minus Z number of neutrons. But when this nuclei is formed, a small mass is lost. This lost mass will convert into the energy, and we will discuss all these mass defect and this lost energy later on in the topic binding energy. But here you have to remember that the mass of the nuclei is given by this expression, where this delta M is the mass defect. So this is the expression for the nuclear mass. Now, most important thing is all these masses like this mass of the nuclei, this mass of the proton, this mass of the neutron, and this delta m. They are all written as in terms of AMU. You will find out in nuclear physics, these masses are in general given in terms of AMU. The full form of this AMU is atomic mass unit. So AMU means atomic mass unit. Atomic mass unit. So AMU or atomic mass unit is the mass unit in nuclear physics, is a general mass unit in the nuclear physics. How can we define this AMU? This is a very small mass unit and its value 1 AMU. 1 AMU. How much is 1 AMU? Can you write down this AMU in terms of kg? Can you write down this in terms of kg? This 1 AMU is always, you have to remember this. This 1 AMU is always equal to 1.66 into 10 to the power minus 27 kg. So 1 AMU is the mass which is equal to 1.66 into 10 to the power minus 27 kg. So this is an important unit. You have to remember this. Another important thing is, you can observe from here, with the help of this formula delta E is equal to delta mc square, you can come to the fact that energy can be converted into the mass and mass can be converted into the energy. So if we convert this 1 AMU mass into the energy, what will be the corresponding or what will be the equivalent energy? So now we have to find out the equivalent energy of 1 AMU. Now you have to find out the equivalent energy of 1 AMU. So equivalent energy, what is the equivalent energy of 1 AMU? We have to calculate this. How will you calculate? We have a formula for this. We have a formula. Delta E is equal to delta mc square. And delta M is here. Delta M is equal to 1 AMU. Delta M is 1 AMU. So substitute this delta M, replace the delta M by 1 AMU, and 1 AMU is equal to 1.66 into 10 to the power minus 27 kg. Into, multiply this by c square. C is the, क्या होता है c? What is the c? C is the speed of the light. C is equal to 3 into 10 to the power 8 meter per second. So we are calculating this in SI unit. So multiply this. This will give us 1.49 into 10 to the power minus 10. This will be equal to 1.49 into 10 to the power minus 10 joule. Joule. We can convert this joule in terms of MeV. I can convert this joule in terms of MeV. If I divide this 1.49 into 10 to the power minus 10 by, I want to convert this in MeV. So to convert this into electron volt, we have to divide this by 1.6 into 10 to the power minus 19. Again, we want to convert it into MeV, million electron volt. So we have to divide this by 10 to the power 6. And you will find out that this comes out to be 931.5 MeV. 931.5 MeV. So this is the conversion unit. Whenever you want to convert 1 AMU mass into energy, then equivalent energy will be 931.5 MeV. This will be the equivalent energy of 1 AMU. And whenever you have energy given in MeV, suppose we have given equal to delta E. Delta E energy is in MeV. We want to find out the corresponding mass. Corresponding to delta E energy. So divide this by 931.5 MeV. This will be MeV per AMU. AMU. So this MEV will cancel out, and what we will have delta E divided by 931.5 AMU. So we can convert 1 AMU mass into the energy in terms of MEV. Whereas at the same time, we can also convert MEV energy into the AMU terms, corresponding mass terms, by using this conversion. So 1 AMU mass is equivalent to 931.5 MeV energy. So this is an important thing. You have to remember two things. 1 AMU is 931.5 MeV, and second is this one, that 1 AMU mass is equal to 1.66 into 10 to the power minus 27 kg. Second important property of the nuclei. Second important property of the nuclei is nuclear radius. How can we calculate the nuclear radius of a nuclei? If we are given a nuclei represented by ZXA, then how can we calculate the nuclear radius of the nuclei? Suppose the nuclei is ZXA. ZXA is the nuclei, and I want to find out the radius of this nuclei. Then formula for nuclear radii. What will be the nuclear radius? Nuclear radius. You can easily find out the nuclear radius by using the formula R equal to R naught e to the power 1 by 3. This R radius is directly proportional to A to the power 1 by 3. What is A? A is the mass number here. A is this mass number here. So mass number to the power 1 by 3. So R is proportional to A to the power 1 by 3. So this is the formula we will use to find out the radius. This formula is basically find out with the help of various experiments. They have performed many experiments. They find out the nuclei of different nuclei. And after this, when they fitted that experimental data, they find out the radius comes out to be proportional to A to the power 1 by 3. So this is a simple expression of the radii you can use to solve the numerical. This is one of the most important formula from the exam point of view, where this R naught is a constant here. Its value varies from one nuclei to another nuclei, and its value lies from 1.1 femtometer of Fermi to 1.5 Fermi. If in a numerical question they are providing you the value of R naught, then that is okay. Whatever value they are providing you, you will use that value. But if they are not giving you any value of R naught, then you will always use this value. R naught is equal to 1.2 Fermi. You will use this value of R naught. So if they are providing you the value of R naught, you will use that particular value. But whenever they are not providing, then you can use this constant R naught equal to 1.2 Fermi. So this is the formula for the nuclear radius of a nuclei. There are many questions which are asked in last few years, which were on the basis of this formula, which can be solved on the basis of this formula. For example, I am giving you an example here how this formula is important. I am giving you an example. Suppose we have a nuclei 29. I have a nuclei 29 Cu64. I have this nuclei, and nuclear radius of this nuclei RCU is equal to 4.8. Is equal to 4.8 into 10 to the power minus 13 centimeters. Suppose this is the radius of this nuclei. Now there is another nuclei. Like 12 Mg27. This is the second nuclei. And now you have to calculate the radius of this nuclei, Rmg. You have to calculate this. So basically, in this type of situation, you will use this formula. In this type of situation, you will use this formula to calculate the nuclear radii. So basically, this formula is important. This formula is important because it can map, it can give a relationship between the radii of the two different nuclei. So basically one nuclei is Cu64, another is Mg27. So this formula will provide us the relationship between the radius of these two nuclei. So apply this formula here. This RCu will be equal to R naught a to the power 1 by 3. For this Cu, a number is 64. So this will be 64 to the power 1 by 3. So this will be how much? This will be 4 R naught. This will be 4 R naught. Similarly for this RMg, this will be equal to R naught. A number is 27. So this will be 27 to the power 1 by 3. So this will be 3 R naught. Now divide these two. Now divide these two equations. So this will give us RMg divided by RCu. And this will be 3 by 4. This will be equal to, R naught will be cancelled out here and this will become 3 by 4. So RMg will be equal to this RMg. This will be equal to 3 by 4 into RCu. What is the value of RCu? This is given. So this is 3 by 4 into 4.8 into 10 power minus 13 centimeter. So this will be equal to 33.6 into 10 power minus 13 centimeters. So this will be equal to 3.6 into 10 power minus 13 centimeters. So in this type of situation, you can apply this formula of nuclear radius. This formula is find out experimentally. This formula is find out experimentally. Now I am giving you another example of this formula, of a numerical which is asked on the basis of this formula. Suppose we have a nuclei O16. This is another example. We have a nuclei O16. Its nuclear radius, suppose that is RO16. That is RO16. Is given by R. Is given by R. And its volume. Volume of O16 is given by 4 by 3 pi R cube. We have a nuclei O16 whose radius is R and its volume is given by 4 by 3 pi R cube. Now there is another nuclei. There is another nuclei that is 54 Xe 128. There is another nuclei 54 Xe 128. Now you have to find out. The volume of this nuclei. You have to find out the volume of this nuclei. So volume of this nuclei is suppose represented by chi Xe, and you have to find out this volume in terms of volume of this O16, which is equal to V. They have written this, that this volume 4 by 3 pi R cube is equal to V. So we have to find out Vxe in terms of V. How will you solve this? It is easy. If you are aware about this formula, you can easily find out. What will be the volume Vxe divided by VO16? What will be Vxe? This will be 4 by 3 pi Rxe cube. This will be equal to 4 by 3 pi RO16 cube. Cube. So this 4 by 3 will be cancelled out, and this Rxe cube. Rxe, this value of Rxe I can write from this formula. So this will be R naught cube. this will be R naught cube, and A to the power 1 by 3 to the power 3 here, so this will be A. So here it will be, what is the value of A here for XC? This is 128. So this will be 128 here. Or you can write here, this is AO16. This is AO16. Similarly here, if I replace this R naught cube, R cube for O16, then this will be equal to R naught cube, or this will be, sorry, here it will be XE, and here this will be AO16. This will be AO16. Because here we have used the formula that RXC is equal to R naught AXE to the power 1 by 3. Make the cube of this, you will find out this expression. Similarly for RO16, this will be R naught AO16 to the power 1 by 3. So we have used these formulas here. This R naught cube will be cancelled out. This R naught cube will be cancelled out. Value of this AXC is 128. 128 divided by, this is 16. For O16, the value of A is 16. So if you divide 128 by 16, this will be equal to 8. This will be equal to 8. Now, volume, this will be VXE will be equal to 8 times V of O16. Volume of O16 nuclei is equal to V. So your answer will be equal to 8V. So your answer is 8V. So volume of this XC nuclei, XC128 nuclei is 8V. This is another example. So this type of questions are asked many times in the exam. So you can use this formula to find out the nuclear radius. Third important property is nuclear density. Another important property is here nuclear density. Third important property is nuclear density. There are two types of densities. One is known as nuclear mass density. Nuclear mass density. What is nuclear mass density? What is nuclear mass density? Here, this is equal to mass of the nuclei, mass of the nuclei divided by volume of the nuclei, divided by volume of the nuclei. This is mass of the nuclei divided by volume of the nuclei. So, for this calculation of nuclear mass density, what we assume? We assume that nuclei is spherically symmetric. Nuclei is of a shape of a sphere. So suppose I am assuming that this nuclei is of spherical shape. Spherical shape, and this nuclei is ZXA. ZXA nuclei, it is of spherical shape. We have assumed that this nuclei is of spherical shape. So what will be the mass of the nuclei? What will be the mass of this nuclei? Mass of the nuclei will be nearly equal to, I am not saying exactly equal, because inside the nuclei we have two types of particle. One is proton, another is nucleon. Combinedly they are known as nucleons. So mass of the nuclei will be nearly equal to the mass of these nucleons. Mass of these nucleons. So what number of nucleons inside this nuclei is A. A is the total number of nucleons inside the nuclei. So mass of the nuclei will be roughly equal to X into 1.66 into 10 power minus 27 kg. Why I am taking this? Because mass of a nucleon, either proton or neutron, is roughly equal to 1 AMU. Mass of the proton as well as mass of the neutron is roughly equal to 1 AMU, and 1 AMU is equal to 1.66 into 10 power minus 27 kg. So mass of the nuclei is nearly equal to this. What is the volume of the nuclei? What is the volume of the nuclei? Volume of the nuclei is equal to 4 by 3 pi r cube. This is the nuclear volume. This is the nuclear volume. Why this is the volume? Because we are considering the nuclei of spherical shape. So substitute this r by, or replace this r by r naught a to the power 1 by 3. So substitute this formula here. So this will become 4 by 3 pi r naught cube a. This will be the formula. This will be the formula. Now substitute these values here. So this will be equal to a into 1.66 into 10 power minus 27 kg divided by 4 by 3 pi r naught cube into a. This a will be cancelled out. A will be cancelled out, and this r naught is nearly equal to 10 power minus 15 meter. This is roughly 1.2 into 10 power minus 15 meter, but we can write down that this r naught is approximately equal to 10 power minus 15 meter, because here we are interested in calculating the order of the nuclear density. So substitute this value here, substitute this value here, and you will find out that this nuclear mass density is nearly equal to 10 to the power 17 kilogram per meter cube. 17 kilogram per meter cube. This is the nuclear density, nuclear mass density. So in this way, one can find out the order of nuclear mass density. There is another density related to the nuclei, that is known as nuclear particle density. That is known as nuclear particle density. Particle density. What is the meaning of nuclear mass density? What is the meaning of nuclear mass density? Nuclear mass density means if we consider the unit volume, 1 meter cube volume of the nuclei material, what will be its mass? This is nuclear mass density. What is nuclear particle density? Nuclear particle density means if we consider 1 meter cube volume, if we consider 1 meter cube volume, unit volume, then how many nucleons will be present in this nuclear volume? In 1 meter cube volume, how many nucleons will be present? So how can we calculate this nuclear particle density? This nuclear particle density? It is easy to write down. It is easy to calculate. We have already calculated that in 1 meter cube, this 10 power 17 kg is the mass. So this nuclear density, if divide this nuclear density gives us the mass in 1 meter cube. Nuclear density is providing us the mass per meter cube. And if we divide this by mass of one nucleon, mass of one nucleon, mass of one nucleon, then we can find out nuclear particle density. Then we can find out nuclear particle density. So this will be equal to, how is nuclear mass density? That is 10 to the power 17 kilogram per meter cube. And what is the mass of one nucleon? This is 1.66 into 10 to the power minus 27. And this is kilogram. So this nuclear mass density comes out to be 10 to the power 44 per nucleons per meter cube. This will be equal to nucleons per meter cube. So nuclear particle density means how many nucleons are present in 1 meter cube volume. This comes out to be 10 to the power 44 nucleons per meter cube.